would be very grateful to introduce. Hello. Ah. Good afternoon for all. Good afternoon. It would be very grateful to introduce our next speaker. Arun N S is working as a principal engineer in WSP and has more than 10 years of experience in transportation engineering, both highways and railway engineering. He is a chartered engineer from UK and also pursuing his engineering license from Canada. He has a diverse profile and portfolio of working in domestic and international projects and has led multiple projects as a team lead. He is also a gold medalist from UVCE, specializing with highway engineering, and also he would be training students in various softwares and technical subjects. And it was also very grateful to tell us that he is the proud alumni of this particular MSRIT college. I would hand over the session with Arun sir. Thank you, sir. Arun sir.
Thanks, Charan. Thanks for that introduction. It was nice saying. I think, yeah, I feel very proud to be a saying MSRIT guy. It's almost 13 years back. I've been studied, pass out in 2009. So it's been a long time that I've been in MSRIT. So
Yeah, thank
you. Yeah, okay. So I'll be sharing my screen. Yeah, sure, Charan. Yeah, I'll be sharing my screen.
Yeah.
Please let me know when you're able to see the screen, Charan.
So we can see it.
Yeah, thank you. So here in this today's topic, I'll be speaking about the geometric design and the modern trends, what we are following and where we have to implement. Because I'll not be going into like what is the transition formula, super elevation formula. Because as a student, as a lecturer, you guys would have been learned in your bachelor's or in master's also. Definitely, you'll be teaching them and you'll be learning them. But I will be explaining you the practical experience, what we have to do it, which are the things we like, what are the softwares we need to learn, what are the codes we have to refer it. So that makes them anybody, you can tell the students also who come out of the, what I can say, colleges, or they can definitely face the interviews very well. So that's the main intention. What I'm telling also the future trends, what we have to foresee, that's what we are presently doing, the current trends, and what the foresee that we are looking at are be the main points I'll be covering on. So these are the contents for this today's presentation. In this today, we'll be learning about introduction, what is geometry design, then practical approaches in that design, then the various standards. I'll be touching upon here on IRC standards because majority I can say about the Indian companies we are speaking. And other things is like the softwares, various softwares. Here I am giving emphasis on safety because I think I saw that there are other say road safety topics are there in the upcoming sessions also, but on what importance we have to give to safety, that is major things we have to consider. And the last, I think the future trends, that is most important. And nowadays the technology has grown in such a way that definitely a future trends, and we have to be well versed and we have to be ready at this present stage. So introductions, like highway is an engineered structure. See, everyone feels that, okay, only the bridges or the buildings are the engineered structures. No, highway is also an engineered structure. You need to design it. You need to sit, whatever be the things, you take it pavement design, you take it geometric design, whatever traffic signal, everything you take it, it's been an engineered structure. And it's an important for everyone's part of daily life. You take it commercial, defense, everything. And one of the best thing is this is the best last mile connectivity. If you go nowadays, if any of the things, they are all striking for the last mile connectivity. If you take road, is the best one, it provides door-to-door service. Still now metro is not it's not a door-to-door service. You need to go to the stations. Okay, so but the road connectivity is what we have. It is where even the airport also take you on the port, anything you take it, but the road is the one is best last mile connectivity. Road geometry is just one branch of highway engineering, because highway engineering as a whole is a very vast subject. It has multiple things: road geometry, then pavement design, traffic engineering, then safety is also nowadays is getting more priority. So this is road geometry is just one of the branch of that one, I can say. The objectives of your highway geometry design mainly deals with to optimize efficiency and safety while considering the cost and also less impact on the environment. Yes, I can put a straight, if I want to travel from A to B, I can put a straight line. That's also on a plan on a screen. It looks correct. Okay, A to B, I'm going in a straight line. But on a practical view, if you want to think of, it's not the best design. We have to consider efficiency, the safety of that alignment, and also the cost and environment. Here, if you think nowadays, more emphasis is given into a carbon footprints or future things where they're telling us to be environmental friendly. So all the things we have to be keep in mind. Also, the geometry design should address the driver and the vehicle consideration, considering the safety and comfort. Yes, nowadays everyone wants to have the safety and the comfort level. So I cannot put extremely sharp curves and tell the driver to drive at high speeds, because it causes more of centrifugal force and causes discomfort. So we should always ensure that we design our alignment or any of the roads with safety and more comfort. And also we have to design for all types of vehicles. We cannot say only this type of vehicles has to travel in this particular road. It's very difficult, since in India, in conditions like India, we have a diverse type of traffic also. Okay, some Ola cars to high efficiency cars. So we have to design our alignment in such a way that we satisfy all the requirements. Also, the proper geometry helps in reduction of accidents. Definitely, we should avoid the black spot studies. Definitely, students should learn in their career also. Definitely, we should avoid such place. Hence, the major objective of this any of the road geometry is to provide a safety in operation at reasonable cost. Because you take anything, any approval finally comes and stays at the financial matters. If it is exceeding the budget, they cancel it. Even if you are designing a best plan, if it's going cost wise, they cancel the project. So we should always design with safety and also with the reasonable cost. So now I'm not going into a detail of, like I can say what is curve modes, but I'll be explaining you the practical approaches how we are to approach a design and how we are to design the roads. So in these images, you can see all types of roads are there, like from the expressways, the national highways, MDR, state highways, junctions. So as an engineer, as a student, if you come out of this colleges, or definitely this makes you understand, okay, I'm designing, say, expressways. What I am designing a 4-lane national highway, so that I'll be understanding that, okay, this is my requirement. This is my design speed. It will be having a median. What are the conditions I need to follow? So first, as an engineer, if you want to learn or if you want to design any of the projects, so we should understand which project I'm designing, because each and every road have their own standards. So it's not that expressway will be followed with the same design speed as a MDR. No, it's not like that. So each and every road has their own specifications. Each and every junctions will have their own specifications. So we should be first, as an engineer, we should understand, okay, I'm designing a national highway, say 4-lane national highway, 6-lane national highway. What are its configurations? Or is okay, it's a 2-lane, what will be my lane width? And what is the median width? How should I approach near the structures? What should be my slopes? So that's what first you should understand, the classifications. If you go through refer IRC, it is very clearly defined each and every road classifications and its specifications. For example, if you're designing a national highways, it says it's an 100 kmph, you have to design it. Expressways goes to 120 kmph. So state highways, if you design it at 80 also, they'll have to. Service roads is 40. So I should understand now what I have to design it. Okay, I'm designing a service road. Okay, I have to design it at 40 kmph, not design it at 100 kmph. So that I should understand very clearly. So now this is the very important thing we should be understanding is the control factors. So design speed is one of the major control factors. So if you see each and everything, your signboards, your curve design, super elevation design, everything is interlinked to this design speed. So your design speed plays a very important role in your designs, geometric design. So when you know that, okay, we learned about classifications. Okay, I'll be designing my 4-lane national highway. Okay, now the control factor is your speed. Okay, now this is my speed. Okay, I'll be designing 100 kmph. That is your major control factor, because all your transition curve designs, which use the three formulas to calculate the maximum transition values, or the radius what you're going to put, or the super elevation, what will be the, everything is linked with the speed. So this is one of the major factors. Now coming into a topography. Yes, topography is nothing but in a local terms, if you can say, is the ground condition. It can be a plain terrain, hilly terrain, because if I can say national highway, if it's a hilly terrain, I cannot design it 100 kmph. So I should also understand my topography. If it's a plain terrain, what should I do? If it's a hilly terrain, or how my design speed is interlinked. So my design speed gradually reduces. How is my recovery radius rate? So that is very important. Then traffic. Traffic in a sense here, we have to understand here is the standard dimensions of the vehicle, because here the lane width, even though it's a standard 3.5 meters is the one single lane width, even there sometimes you need to design for the extra vehicles. Sometimes this type of conditions will arise in, especially in defense roads or something like that. But as an engineer, you should also understand the traffic and the design vehicles. So environment nowadays, if you cannot go near the forest areas, forest lands will be a problem. If it's in heritage, for example, we have to understand it. Heritage buildings are there, so environmental conditions are there. So we have to think of like, okay, I cannot design my alignment going near to the forest, so because it impacts the fauna. So what we have to do it, we have to think of like, okay, where we should do it, how my alignment has to go it. So this is also one of your control factors. It means if an environmental impact is there, you have to modify it because it indirectly affects your alignment. Then human tendency, yes. Human tendency behavior is very important, because I think all of you guys would have been learned the side distance calculations. How the side distance, PIV theory, how it is in human tendency. The reaction time of the driver. So that also have an influence on your alignment design. Then economy, that's I can say it, everything that runs up and says, okay, if it is cost within my budget, okay, then I can get an approval, because I cannot say everything, okay, if I'm doing it in this section, I'll put a tunnel. No, it cannot be done like that. If I put a tunnel there, it definitely costs you more. And aesthetics, for example, aesthetics is I can say it's a least thing where we'll be giving, but as in nowadays, it's a trend is going on, like we have to design our roads which looks very beautiful. The surroundings areas looks beautiful. If you see some of these street roads in any foreign countries, it looks beautiful between the buildings it runs. The aesthetics also is an importance has been given nowadays. So before then, we have to start for the alignment design, say horizontal and vertical design. I should be knowing this. What type of cross sections? What is my width of the carriage? What are the components that is coming up? Here, I have just put one sample cross section. This is basically under the underpass. I can say vehicular underpass or any underpasses, you can take it. So I know my carriageway, clear carriageway width is 11 meters. There is a crash barrier. There is a footpath, then also service road and drain. So I'll be knowing that, okay, this is my, this is the right, within my right of way, I have to design this completely. Okay, I have to design my service road. I have to design my footpath drain. I have to design my carriageway, which should also has a footpath means in the bridge location. So when I know that, okay, my right of way is only 40 meters. Generally for a 4-lane, they'll give us right of way as a 40 meters. So within this 40 meters, I have to fit this entire component. So if you take it as stop as 16 meters, your 5.5, it's almost 11, 26, 30, 27 meters plus 2 to 4. It's almost 30, 31 meters. Plus extra side slope, which becomes as 2.5. So you'll be understanding that, okay, within 40 meters, I have to fit this components. So now you know my classifications, my control factors. Now I know the cross sections. So knowing this, all components, each and everything, then we can go and start your designs. So as I was mentioning earlier, alignment design is basically bifurcated into two types, like horizontal design and the vertical designs. So horizontal design is basically made up of like from a tangent, transition curve, a spiral curve, then again a transition curve, and again coming back to tangent. if a curve it is been designed with more than 1850 meter radius, there will be not a transition because you don't need to provide any super elevation things. With all the normal camber that is being provided will take care the super elevation effect. So I will not be going into like what is the various types. There are 5 types of side distances. So you'll be definitely learning that, like what is the stopping side distance, intermediate side distance, overtaking side distance, headlight side distance, and saved side distance. So we should practically, why I am telling you on side distances, okay, now I'm designing my 4-lane divided carriageway. I will be not concentrating on my overtaking side distance, because overtaking side distance will not come into picture if I'm designing a 4-lane divided carriageway, because your traffics have been bifurcated by a median. So overtaking side distance will not come into picture. So as an engineer, we should not think of, okay, whether I designed alignment, I have to check with OSD. No, because it's, if I design it with my ISD conditions or SSD conditions, that is more than enough. So that's how we have to make your job very, very simple. Because you know all the types of side distance are there. Okay, I need to check each and every side distance. No, you have, since you know what you're designing, you can bifurcate into such things. Then transition curves. That's also one of the things. You know that there are multiple 3 formulas are there. You have to calculate it and you have to arrive. And also super elevation. See, super elevation as well, the formula will get more. But if you refer any of the codal books, if it says for national highways, you cannot design more than 5% super elevation. That means then what you have to do it? You have to improve your curve. You have to improve your speed or reduce the speed, whatever conditions based on site conditions, you have to do it. Then curve, there are various types of curves like simple curve, compound curves, reverse curves. See, there are many conditions. Okay, when you learn in a student, we'll be learning about, okay, simple curve, where we have to provide reverse curve, where cannot provide the reverse curve, how compound curves can be provided, how when I provide a compound curve, how the transition will be impacted, how the transition will overlap one about the other. So that is what importance has to be learned. Then extra widening. So if I'm designing a 4-lane divided carriageway, extra widening cannot come into picture at all, because as per the standards, extra widening will not be given on a 4-lane, because extra widening is provided only on the curves less than 400 meter radius. So, but here in a national highway 6, the minimum radius has to be provided 400 meters. So how the trend is going on, see, you will learn all things as a student or anything, you will be learning. But when you come out, these are the various things which makes your life very simple, because you should be knowing extra winding. Okay, extra winding is mechanical winding plus psychological winding together gives me an extra total width I have to provide to the carriageway. Yes, but you should understand it. Okay, that comes in when you, especially in a 2-lane carriageways. But when I'm designing a 4-lane carriageways, it does not matter. So the trends are changing. How you have to bifurcate to make your job easier. This is what you have to learn the most thing. As when it will be definitely helpful for you to, like, when you face your interviews or anything, when you come out of your college life, it will definitely help you out. Okay, I know the extra widening, but somebody says a scenario, okay, you're designing a 4-lane carriageways. What is extra widening? You can directly say, no, there is no need to provide extra widening. That's how the importance you have to learn how the trend is. When the softwares are developed in such a way that even if you by mistakes you provide it also, it gives you a warning signal. That's the trends are setting up. Even the everything, each and everything is been inbuilt into a softwares nowadays. Now coming into vertical design, yes, the gradient is one of the most important thing. Whether the up gradient, down gradient, what is the minimum gradient we have to provide? See, we cannot give a 0% flat gradient, because the drainage is, because water is one of the enemy for our payments. So we have to ensure a minimum 0.3% longitudinal gradient is being provided so that water gets drained away easily. So that is one of the important things. Okay, and approach to the structures. If in the previous slides you saw the cross sections of a vehicle underpass. See, you learned, okay, gradient in a plain terrain, you have to provide it, say 5, we cannot go more than 3%, 3.3%. Yes. But there is some special conditions which generally, any of the textbooks you would have not learned it. is what approach to the structures, any of the bridge structures, any of the underpasses when you're designing your profile, it should not go beyond 2.5%. That's the condition. That's the trend that has been changed. That's what is the updated versions of the code book says here. So the summit and sag curves here, the side distance again comes into picture. Your vertical curve should match the side distance conditions. For example, if you're giving a summit curve, it has to minimum it depends on the speed also. For 100 kmph, you're providing a summit curve. Say you have to give that algebraic difference, say up and down. What is the if a summit curve is up and down, so that you get a summit curve. So we have to give a minimum vertical curve as per the calculation for SSD condition or ISD condition, whatever you're designing it. And when you're designing your sag curves, definitely you have to give importance for your headlight side distance. You learned side distances. What is the importance of side distance? But where to implement, where it is getting implemented. So headlight side distance is given more concentration when you're designing your vertical alignment, especially in that also sag curves or valley curves, whatever you can call it, a sag or valley curves. So here you'll be giving more importance on your headlight side distances. Then curve compensation, because this is where more of the things I will not be learning, because curve compensation is the thing. When you're designing your vertical alignment on horizontal curves, we should provide a curve compensation, because the centrifugal force effect you have to take place. You know how the centrifugal force, you're providing super elevation, but here also you have to adjust the gradient. If I say a maximum gradient, rolling gradient is 3.3 for a plane road. So if a horizontal curve, with respect to horizontal curve, we have to reduce the gradient. That means you cannot go provide the gradient above that. And minimum requirements as per side distance is nothing but the vertical curves. So as for national highway, the minimum vertical curve length should be 60 meters, minimum at any condition. But based on the design speed, based on the gradients that has been provided for SSD condition or OSD condition or headlight side distance, we have to calculate and provide that particular side distances. So this is basically about the alignment designs. Why I'm not pushing on what is the formulas, like what is the superposition b square by 225? No, because you as a student will definitely learn. But which are the things which you are not learning is basically why I'm not providing a 7%. When you calculate any formula and put a say sharper radius, you will get superelevation of say 8%, 9%. But that is not at all allowed. That is not at all been constructed in the road. So as a theoretical subject, it's correct. As per the particular speed, particular radius, we are providing that superelevation as the formula. Superelevation will come as say 10%, 11%. But on actual, we will be restricting it to 5% for say national highways. So that is how it is. This is the changes that has been happening. So that's we have to give more concentration on. And it will also help you out when you come out into the interviews, when you complete your bachelor's or master's degree. That will be very helpful. So these are the various standards I want to emphasize when you're learning a geometry design, because this is very important nowadays. It gives you a theoretical subject also. It gives you a practical experience also. And what are the minimum values we have to follow? So if you refer IRC 38, guidelines for the design of horizontal curve for highways and design tables. It covers all types of roads, starting from say service road to the national highways. It speaks about each and every topic, setbacks, then transition curve values, super elevation values, each and every value for each and every speed, each and every terrain condition. Along with your Karnal Just or any whatever the textbooks you're referring, also refer this one particular code, which is this in open source. If you type in Google IRC 38, you'll definitely get it. So along with this textbook, what you're learning, or say horizontal design I'm learning, refer this book also. Refer this particular code I mean to say. Then it will give you a complete picture. Say how practical approach they have given it with the diagram, how the curve is being drawn, what is mid ordinate, what is the components of the curves, each and everything is been defined there. how that same transition formulas, what is written in textbook is for written here else also, but how to implement it, where to implement it. For example, when the curve radius goes, say, when you're providing a horizontal curve radius of 5,000 meters, the code says no need to provide transition. But as per the formulas, if you calculate it, it requires. But on practical note, it is not required. So when you learn both along with the code, a textbook, that will give you more weightage and make you more technically strong. And IRC SP23 is purely for vertical curves, just like how the horizontal curve you are designing. Vertical alignment can be learned through IRC SP23. Then IRC 86C. This is the geometry design standards for urban roads. Okay, now when you're designing for urban roads, you should not refer the code book of IRC 38. You should refer the code book for IRC 86. That's how, because the standards vary, because the speed conditions vary, the terrain conditions, because on urban roads, most it will be a plain terrain. The ROW widths will vary, the cross sections will vary. So the code book reference should also vary. Then hill roads, when you're designing an hill roads, you have to refer IRC SP48. Then IRC SP52 also recommendation about alignment survey, how to do an alignment survey in geometry design hill roads. Because you will be learning about how to design a survey, by chain or topographic survey, total station using total station. But how many points has to be picked up in a sharp curve every 5 meters? That is what you will be going to learn in technical part. When you refer these codes along with your studies, say, I'm not saying when you're learning about your, say, surveys, okay, I'm doing my survey. Now I just refer it. Okay, what are the things I have to do in practical point of view? It will give you a more detail. So how to use a total station, you know it. But just in a straight person, if you take it at every 10 meters, is good. But if there is a curve, you need to take it at every 5 meters, the survey points. That's what you'll be learning. And similarly, you have codes for cycle tracks. Nowadays, I think if you see anybody is all going for a friendly ones for the pedestrian and cycle tracks. So cycle tracks has a special code IRC 11. Then IRC 66 recommends practice for side distance of life. I'll definitely refer all the students or anybody or teachers, whenever you're teaching them side distance, definitely keep this IRC 66 open. It will give you a very practical approach also of side distance. All the 5 types of side distance: stopping side distance, intermediate side distance, overtaking. Each and everything has been defined here also. Each and every formula, what you learn there in the braking distance or lagging distance, everything is been meant here. But how it has been practically implemented on the highways is been clearly given here. When you learn both together, it will be very good for both all of us. Then now when it comes to interchanges, nowadays if you see beautiful interchanges, I can see just given here Embal flyover. So it's a beautiful interchange from the, if you see the top view, that's guidelines changes for that. The curve speed, the curve designs, the curve radius, everything changes. So IRC 92 gives that. Now, since a 2-lane road, 4-lane, 6-lane, and even for expressways, IRC has recommended a special board. This SP stands for special publications. So they have given a specific standards. When you're designing a 4-lane national highway, you have to justify each and everything. Each and everything has to be coming with respect to IRC SP84. That's how each and every code book defines you, each and every standards, for even for horizontal curve, anything for geometry design, even for payment design also. If somebody is designing, you have to write, okay, IRC 37 for flexible, IRC 58 is fine. But SP84 also set some standards. This is a minimum thing we have to follow. This is a minimum MSA you have to follow. So that's where you'll be learning all the practical points of it. So now coming into the software, this is how we're now presently we are working. We are sitting in our office. We are sitting at from home and delivering the projects outside. Well, thanks to technology. But there are various software I'll definitely tell us to teachers and also the students. Nowadays, MX Road, please, I think if somebody wants to learn anything, MX Road is an outdated one now. Please don't study that one. I'll now go to Open Roads. It's an updated, Open Roads is an updated version of MX Road. So please, if somebody wants to learn any software, any highway technology, go for Open Roads. If the MX road is already outdated and none of them are basically using this MX road. And also Civil 3D, these are the open roads, and Civil 3D are the two major softwares that are being utilized in the industry right now. I can say majority of throughout the world. I can say 1 or 2 countries where they have their own softwares. Like in Australia, they use 20 softwares. But I can say in India or anywhere, UK or America, anywhere you go, they are on Western sides, Civil 3D and open roads are the two major things they are utilizing as a software for the design. You can see this is the plan view. Where on my right hand side, you can see my cursor is moving. This is about the plan view. This is what the junctions are. These junctions. So everything can be neatly defined here. And nowadays, when I'm next telling you about the future designs, you'll be just sitting in here and designing somewhere in America, any particular road. You can sit and view it. That's what the technology is going on, and that's the future trends that will be there. And infra works, I'll be telling if a student wants to learn it, definitely it's a very important thing, because before you start your actual design, you can show to your client, say, by working on infra works, it gives you a quick alignment, I can say, and it gives a 3D view, complete 3D view it will provide you. That's what, if you want to see, I can say an alignment, how it goes in front of it, you can definitely see everything. It's support of Google Earth. You can easily see everything. And also in initial estimation can also be done. Approximate quantities like cut and fill quantities can also be done. So what does the software does it? See, as an engineer, as what you're coming up, we have to give the inputs. Okay, so all the inputs, whatever inputs we have to do we have to feed. Software does not do it. So whatever data you feed, accordingly the design will come. Say if you want to fit 500-meter radius, you can feed it. The software will give it whether it is possibilities, error is there, it will highlight it, but it will not tell you this exact value has to be. So as an engineer, you have to put this value. So analysis of ground data. So what is this analysis of ground data? When you do a topographical survey, okay, now when you're doing seven semester, when you do a surveying, okay, you do using a total station, you calculate a survey because there will be ups and downs in the ground. Sometimes you would have kept your this one level bar where at some building. So such type of things we remove it. That is called analysis of ground data. Sometimes you put values 0 by mistake, you type it 0 as Z values. So such type of values we have. This is called analysis of ground data. Then we create a ground model. So once your unnecessary data has been removed, then we create your digital terrain model. That means by using a software, will create your ground surface. So that is your base. That means that will be your actual ground. Then we'll be learning then you'll start designing your horizontal alignment. Then horizontal alignment, basically your tangent, you'll put it, then transition curve, then normal simple curves. That's what you learn as a technical part that you'll be feeding into the software. So it designs your horizontal alignment, vertical alignment, then you create your cross sections, because this will be helping you out in estimation of quantities, and also design of intersection and junctions, and finally drawing preparations. Yes, because whatever design on the software, because these are the final outputs, I can say, which you are seeing on my screen, the images with signboards. This is junction design. This is the one of the plan view where it's a curve. You'll be giving this is the curve boxes, which will give you all the details, like say what I can say, the curve radius, the speed, the super elevation, what is so, and during execution, if a construction person can refer this, it will be giving you all the details, the XY coordinates. So this is how the software helps you. Please remember, you have to give the proper inputs, then only your design will come out better. So nowadays, if you see, any of the roads are open to public after safety audit only. So without safety, earlier I can say 5-10 years back, if you design the road, okay, it gets approved, so it is here. But nowadays, a mandatorily North has specified, or the National Highways has specified, that safety is a priority and it has to be audited. That means each and every design is being checked with the constructed one. So that means safety audit will be happening during the day also and during the night view also. That means during headlight view condition also, a safety point will be done. So both during day and night, a safety audit person will do it check, and then if he will give a comments, and then finally he will approve this can be open to traffic. Until that, none of the roads will get open to traffic, even though if it's been completed and until its audit is not done, it will not be open. So why I'm bringing this safety into a picture? Because it's of high priority nowadays. If you see the accidents has been happening, we have to reduce. How do you showcase? You can showcase yourself by designing a beautiful road which is comfort and non-accident roads. Safety should always be your priority. Authorities and IRC and all other standards are meant to be followed to ensure our designs are of highest quality and safe to the road users. Yes, there are so many code books. Each one defines for each. Why? Because we need to follow that one to ensure that it has been designed for highest quality and safe to the road users. In a safe system approach to the road safety, the problems must be dealt in consultation with all highway considerations rather than isolated. For example, if say there is a black spot, okay, there is a sharp curve is there. So not only a geometric point of view, we have to think of, okay, I have to consult my traffic engineer. Why the accidents happening? Why they are approaching at higher speed? Okay, if there is no proper signboards up there, if by chance by humps up, so what we have to like consultation with all the people, we have to work and ensure a safety approach is being done. For safe system approach, user-centered design guidelines, including a road safety audit. That's what I've already covered it. Combining safety and human behavior in your life. Yes, this is very important, and this is the trend that is going on. They are bringing human behavior. Okay, if you see anywhere nowadays, you will get a message. It's technology is growing up. There is a traffic jam ahead. There is a like a what I can say. There is a sharp ahead. Nowadays, if you see a 3D view in any of the high-end cars, you can see the road ahead. It will give you the approach. Okay, it's 3D views are getting in your car itself nowadays. So also now we have to give safety training to highway engineers. 3D designs we have to do like modeling and view it before implementation. This is very, very important nowadays. So this is what I would like to speak about much more here, because this is the future trends, because this is the younger generation that has been coming out. We have to design and should focus on future ready designs. See, future ready means now you are in 2022, but your roads are designed for 15 years, 30 years when you're designing. We have to think of like so many vehicle modifications will happen, land use patterns will change, environmental conditions factors will come into picture. So you have to keep in mind that you design your roads in such a way that they are future ready. So nowadays, I can say each and every drawing today is gone now. All the plan view what is on papers is gone nowadays. Each one and everyone are designing in 3D view. You sit in the office, you sit anywhere in the world, you can see your designs. Visualization, you can put the vehicles in motion. You can put the street lights. You can see whether the largest vehicle is able to take the curve, whether any accidents will happen, whether it's overrunning or whether it's hitting any of the medians or curve. So this 3D visualization is the one of the ongoing trend, and definitely it will run, and moreover like 4D 5Ds are coming in. So this is very, very important. Also, now gone are the days these are the future trends. These are the future trends that is coming up. So this is very, very important. Sorry. So LiDAR surveys are widely used. So quality of mobile data collection improves. Designers have the opportunity to develop high resolution models. Okay. Now when they're using a drone survey, you get it by 1 centimeter by 1 centimeter. And even information of greater detail are their accuracy than possible with the traditional surveys. Because in traditional survey, when you're using total station, you will not get so much accuracy. But the LiDAR surveys or even the what I can say drone surveys are very much improved, and it gives a minute details at every 1 mm also you can get a detail. Then context setting and design, and because flexible design is a commitment to safety and mobility, because you don't know what type of vehicles. Nowadays, we have this type of vehicles. The technology is growing on how the petrol vehicles will go on into EV vehicles. When maybe that there can be dimension changes can happen. The more of buses or bigger vehicles can come. So we should be designing in such a way that we should be future ready, environmental friendly, and also simultaneously advanced safety mobility enhancement to the natural environment. Because nowadays, if you see any of the budget is given or any of the things, carbon footprints, you have to reduce it. That means carbon footprints is like basically your carbon dioxide, what's we called. You design your environment, you say use of fly ash in your payment design is one of the reducing the carbon footprints. So that's how the more importance. Now more importance is given to the cycles, the footpath, so people pedestrian walking. So this is how the more importance has been given. The interactive highway safety design model. This is basically computer-based tool that facilitates the evaluation of safety implications in design through planning, design, each and every step from your planning to the till the execution. Safety has been given highest priority. And now ITS technology, this is the way more trending. I think this is also becoming one of the disciplines I can say in many of the organizations. This is basically a technology. Each and if you see, I was reading an article today in LinkedIn. If you just throw anything while, like say you have a Domino's or something, you just throw the paper, the system will detect your license plate number and it will send you a fine to your home. That's how the technology has been growing up. So similarly, in geometric design also, they are bringing it. Several ITs technology have potential significant affect geometric design of it because it's not the normal trend that we are following. Nowadays, high technology, I can say, use of headlights, automatic braking systems. So if many would have seen that Volvo, even if a small vehicle is there, automatic brake applications are there. If you see Tesla, automatic self without driver, it is going on. So you have to design in such a way that see normal side distance when you calculate it, okay, minimum stopping side is 180 meters is there. Now a driverless car is coming. So human technology, human behavior goes out of picture. So everything runs on artificial intelligence. Now machine is doing your driving. So accordingly, your designs also will change. So this is the trends that will be coming up in the upcoming. So we have to be, what I can say, we have to modify ourselves to such a situation that going in another 5 years, in another 10 years, when you're getting a driverless cars, driverless trains. So we have to design our alignments in such a way that it suits them. We cannot have so many curves, we cannot have so many junctions. Then when you're just reaching from A to B will take a lot of time because machines have been fixed with such conditions. Because if it sees a pedestrian, it will stop automatically. So we have to design in such a way that then simultaneous vehicle infrastructure design. As I was mentioning, yes, vehicle will change. Now automatic two-wheelers will come. It becomes more conditions. Then big cars may reduce it. Bigger vehicles become hydrogen vehicles. Whatever conditions, even electrical. If you go, I think in Sweden or some maybe in Germany, there is vehicles running on electricity. They have to give the OCS type of tracks. That means the electrical cables are running above the road. So that's how the modification infrastructure we have to do it. Then special use highways. This may be conditions very difficult, but special use highways and transportation not available to general public. For example, bus and HOV lines. That means when coming up, this is only meant for you learn okay bus lane. Many things there in Bangalore they did it for OR outer ring roads, but it failed. So this is something which we need to make it. I can say going forward, definitely it will be one of the priority. A bus lane for heavy vehicles, we should design separate lanes so that congestions avoid. Then vehicle to infrastructure, vehicle to vehicle communications. Nowadays, the technology, just a message will be displaying on your screens. Automatically, will be displaying in the future. What is that? There is a snowfall ahead. Okay, the temperature is there, this much. There is a traffic block there. So definitely all this decision regarding geometry design will have an influence. So these are the trends that we should follow further and ensure that we also adopt to the technology and we also design one by one accordingly. So thank you. Any questions?
So thank you, Mr. Arun N S, for your nice presentation. I think some questions are there in chat box. I'll read for it.
Okay.
So first one is from Dr. Amardeep. So he's asking, in civil 3D software simulation is, I think in civil 3D software simulation is possible or not for unsignalized intersection?
Sir, going forward, I think civil 3D is also updating. At present, if you see the civil present question is like say 2020, 2021, you can simulate it. You can learn, but when if you use it as say InfraWorks, you bring it your alignment design into InfraWorks or Navisworks, you can visualize there. You can put the vehicles, you can put the signboards, even at what speed you are designing it. For example, you design it for say for 80 kmph or 100 kmph. You can put it there. You can visualize and can signalize intersections. I have not seen it, to be frank, but for the normal roads, definitely we can visualize and simulate. Even for there is auto turn also for the longest vehicles, say 18-meter vehicles in a junction design. We can run that vehicle and see the path of the vehicle. That means because the front axle and back axle will not follow the same path. So when your back axle follow different path, whether it's going and hitting the median or hitting any curve, each and everything can be simulated.
Now, the second question is from Mr. Ashok Kumar.
Yeah.
So he's asking how to learn application of input methods in geometric design of roads.
Yeah, see, input method can be like when you get proposed survey. See, what I can say with respect to software, if I want to say, I can say inputs can be through Excel sheets, and then it can be through AutoCAD data or DGN, I can say. So these are the various methods where survey inputs can come. The LIDARs, XML formats. See, if I want to learn, these are the various methods you can input your survey data into your softwares. This is what he is asking, what the inputs method he is asking, or what exactly his question maybe, Ashok? Question.
How to learn application of input methods in geometric design of roads.
Sir, this is Ashok here, sir. Can I ask?
Okay.
Yeah, sure.
Okay. Usually in MX Road, we usually use that Genu files to automatically run.
Correct. But Genu files are basically what you, once you already inputted the data, then you create a Genu files. Okay, if somebody has designed already, then you will get a Genu file. If you are freshly designing your alignment design, then say you get a topo survey data, you basically get it from what I can say a total station or any LIDAR survey. Then you have to get it in an Excel sheet format, then XML format, or DWG, DGN format. These are the basic major inputs which we want to import it. Then you design, then you're getting a Genu file. Genu file is basically a text file. Or somebody, for example, I already designed it. You want to improve it. I can send a Genu file. Then you import it, that Genu file, that you can continue the further design. But as a fresh design, you won't get a Genu file.
We can record this in open roads and civil 3D. Still, we can record.
Yes, there are some civil 3D is entirely different because civil 3D runs on AutoCAD background, and this on open roads and MX Road runs on MicroStation background because the company itself, one is Bentley and one is Autodesk. So the platform of there is entirely different.
It means we have to do it manually. What we are saying, sir. Both the design.
Initially you have to design it. Then you can share directly. For example, when you design in open roads. Okay, nowadays it's just a DGN file. You can just transfer it to somebody. It will be there, and he can continue the design. For example, it's 100-kilometer roads is there. You cannot design 100 kilometers road because it takes a lot of time. So it will be bifurcated. Say A will design 30, Arun will design 30 kilometers, Ashok will design 30 kilometers. So for example, I designed 30 kilometers initial concept. So you have to continue it further. So that means you have to overlap my design center line. So I can send you a DGN file or Genu file to you. Then you can continue from there further. But as a fresh design, okay, it's no, you have to start as a fresh. You won't get a Genu file for any.
So in civil 3D, usually we the file size is usually larger. How to reduce it, sir? Usually we have this problem.
Yeah, definitely. In civil 3D, when you're handling, if you have to break it, I can say that's the easiest way. Because we can later merge it, the design application, because when you have huge data, say we cannot input all the 100 kilometers data and design, definitely your system will crash. As of I know, what are the biggest organization also giving a 32 GB RAM or 64 GB RAM also. Definitely, it is not supporting any of the files, because practically I am also facing the same thing. It is crashes. So what we can do the best is divide the data, take up small inputs, well, I can say 10 kilometers, then design it, because you can merge that design.
Okay.
So that's not a power problem. So that is the best way, simple way I can do it.
Okay. That's good. Thank you, sir. Wonderful presentation, sir. Very
Yeah, thanks. Yeah, Ashok.
Sir, one more question is there.
Yeah.
Hello, can you hear me?
Yeah, I can hear it. Go ahead.
Okay,
Sir.
okay. So this is regarding the estimation part. So
Okay.
whether you can extract the earthwork quantities from the software.
Yes, sir. I'll tell you, you don't need to sit and do any of the calculation. Not only earthwork calculation, even your pavement thickness also. For any of the stretch, say you take 100 kilometers also, it will give you by every 5 meters you want the quantity, every meter you want the quantity, you will get it, sir. Every earthwork cut, fill, everything, each and everything estimation can be done.
Okay. One more question is, what about the accuracy of the data?
Accuracy of the data is what you input, sir. For example, if you say pavement thickness as you say BC, you're putting as a 50 mm, definitely it will calculate according to which carriageway width. So whatever the inputs, your accuracy is 100%, then software output is 100%. Sir. There is no nothing calculations goes wrong.
No. The question is this: suppose the software will take from DTM models.
Correct.
Correct.
Yes.
So if the survey points has some, suppose 3 points are there.
Yeah.
So first and second points he has taken, and in between the surveyor missed some points.
Correct. Yes, sir. So that means, sir, when you've taken a say total station data, I told you analysis of survey data. That means you are analyzing. That means there can be humps and there can be depressions can be there. So you have to delete that, because see, I'll tell you, everything software does it only what we feed it. So software does not take it manually. It will not overthink it and do it. Whatever you feed it. So this is the survey data. For that survey data, it is giving the quantities. If your survey data is not 100% accuracy, it's only 95% accuracy, then you also have to take, for example, your cut quantity or fill quantity, say 100 cubic meters, add some 10 cubic meter extra, because that's how it will, as a quantity estimation or anyone is going to bid also, definitely take it, because to be on a safer side, because wastages will happen. So keeping that in mind, we have to take some 10%, 5% extra to the total quantities what we get. So.
Okay. Now, for faculties and engineering college, for teaching the students, which software you can recommend? Because we may have.
Sir, nowadays everyone was selling the MX Road. I would definitely suggest don't go it, because if when you come out of your engineering college and you say MX Road, nobody is going at present. Nobody is utilizing it. So you can go to Open Roads, which is an updated version of MX Road, I can say, and Civil 3D, because these are the two softwares in India which has been continuously used by any MNC. You take it, any local company, anywhere. These are the two softwares which are being utilized mostly, sir.
Okay.
And I've definitely, even when I my colleges, when I meet my lecturers, I would say, definitely, when you're learning, I was just telling you, sir, when you're learning a theoretical subject, okay, when you're learning from second hand just to textbook, you're learning, okay. So along with these code books, what I mentioned in this presentation, if we learn together, right, definitely when the student comes out of his college or somewhere, he will be standing out. That's what I always tell whenever somebody comes to me here. Definitely, that's what I also teach them. You learn along with your subjects, their theoretical subjects, and say I was to mention you super elevation. Yes, formula is same. Even in the code book also it says v square by 225. But how it is been applied here, how the various methods of applications are there, where the value should be restricted. So that is very important. If you learn together as a course, that is always helpful. That's what I always recommend to the teachers or anybody when I meet them.
Okay. So I think there is no other questions. So I thank sir for his wonderful presentation on highway geometric design. What I feel is this topic is very much important with respect to consultancy aspects, and when you go to any industry, I think you are much need of a geometric design engineer. So thank you once again from Department of Civil Engineering, MSRIT. Thank you, sir, for your nice presentation. Thank you.
Thanks for the opportunity, sir. Definitely, I would like to thank, and it's my college. and always pleasure for
Okay,
me.
okay.
So I'm also an ex-alumni of this college.
Okay. Good.
Thank you.
Thank you.
Thank you.
Thank you. Now, participant, you can wait for 5 minutes. I have an announcement to make.
So I shall leave, sir.
Sir, you can leave, please.
Okay. Thank you, sir.
Thank you. So with that, we have come to an end of our third day sessions. So today we are having 3 sessions. First by Dr. Partham Pradim De, mainly on the talk of mediums. So sir has talked about various theoretical and practical aspects of median openings, and his session was very informative and throw lights to new areas of research in traffic engineering. Second session was by Dr. Nisar Ahmed, our own faculty, who has got very wide experience in surveying, not in India, in foreign countries also. So sir has briefly explained the advanced techniques, starting with aerial survey to LiDAR survey. He also covered some of the work he has done in Saudi Arabia. It was very useful and informative. The third was just concluded by Mr. Arun N S. He has done an in-depth presentation with basics of geometric design with various software which is used in the field commonly and abroad also. The future trends in geometric design like interactive highway safety design model, simultaneous vehicle and infrastructure design, etc. was discussed in detail. We hope that these 3 sessions was very useful to you. So we will meet tomorrow at 9:45 and sessions will start at 10. So on the behalf of the department and college, I thank you all. Thank you.